This is an example of a double sampling plan. This is question 1b of the June 13 SS06 paper. A double sampling plan is suggested to monitor the production of the EMC device. A random sample of 20 EMC devices is taken from a large batch. The batch is accepted if no non-conforming devices are found in the sample. The batch is outright rejected if 2 or more non-conforming devices are found in the batch. Otherwise, a second random sample of 20 devices is taken and the batch is accepted if a total of 2 or fewer non-conforming devices are found in the 40 devices sampled. The first question asks us to find the probability of accepting a batch containing 3% non-conforming devices. This means we have a binomial situation where n is 20 and the probability of acceptance is 0.03. or the percentage of non-conforming devices, 3%, I beg your pardon here. So what we need to do in order to have a solution here is to think of it probably as a tree diagram. The question said that we would outright accept the batch if there were no non-conforming items, and the probability of that happening when we use a binomial distribution where x is binomially distributed with 20 and the proportion of non-conforming items is 0.03, the probability of x being equal to 0 is 0.5438. That is probably going to be calculated using a graphics calculator, and that would then be the BPD function on the calculator where x was 0, n was 20 and p was 0.03. We outright reject the batch if we have 2 or more non-conforming items. We don't need to calculate the probability of that because that doesn't constitute our acceptance. The other way in which we can accept the batch is if in the first sample we only have one non-conforming item. The probability of that again is a BPD from the calculator, and that's 1, 20 and 0.03, and if you enter those into the calculator the probability of that is 0.3364. If we have one non-conforming item though, it then dictates that we take a second sample of 20 items. The probability that we have to take the sample is 0.3364, and then we accept the second sample if in total we have no more than 2 or so it's 2 or fewer non-conforming items overall. So if we've already had 1 from the first batch, we need this one to be less than or equal to 1. i.e. we will accept if we have no non-conforming items or 1 non-conforming item in this second sample. So a subtle difference here is that we now use BCD on the graphics calculator because we want 0 or 1, and it's going to be BCD 1, 20 and 0.03, and the probability of that is 0.8802. The total probability then of us accepting is the 0.5438 from the top branch plus the chance that we have to take a second sample, which is 0.3364, multiplied by the occurrence of 1 or fewer items, 0.8802. And if we put those into a calculator, we get 0.840 as our value. Okay. Part 2 asks us to calculate the expected number of devices that sampled from a batch containing 3% non-conforming items. We have to take 20 because that's our first batch, and we then add to that the expected number from the second sample of 20. Well, the probability that we have to take a second sample is 0.3364, and the number in that sample is 20. So if we add those together, we get 26.7 items to 3 significant figures. And that concludes the question.